Computers provide endless possibilities for one to create music, and when experimenting, new results are easily achievable by simply adding, subtracting, or adjusting features within a composition. While one can use software on computers to create music on audio interfaces, it is important to learn how one can utilize an unlikely aspect of computers, connection ports, by grabbing a USB cord, connecting a microcontroller, which is a sensor type of transducer that changes electricity input to sound output, to a computer is a simple task. The computer will act as a power source, lighting up a small light which indicates your Arduino is ready to sing through the computer. However, it can't sing if it has no vocal cords to move, which is where resistors come in. The microcontroller utilizes 5 volts of power, which pass through a resistor which can vary in type and amount connected to the microcontroller board. Resistors reduce current flow when connected to an electrical process. During our trials, the frequency and pitch of the tune changes whenever the resistor is adjusted to open and close flow pathways as desired. We first added a flex sensor resistor, which is folded and unfolded in different directions and is heard changing the frequency of the sound. This can also be achieved by adding potentiometers, which are manually adjustable and contain 3 terminals to attach to the microcontroller board, in a similar way to how flex sensors must be attached carefully to the individual wire locations to accurately read its movement input. These resistor attachments were connected to the board through specific slots called pins. There are 2 kinds, analog and digital, where the values are read through voltage levels that affect the amount of energy and pitch change allowed inside of the audio interface being used. The analog pin, in our case A3, must match the setting in the interface it is plugged into, A3 as well, and is attached to a potentiometer that will read the constant amount of voltage input. In the digital pin, another potentiometer is attached and will read a range of values that account for the changes in pitch. One important thing to note is that sound production with this method is reliant on resistance configuration. We had an issue with our process where no sounds or changes would occur when the flex sensor would move. To fix it, we changed our configuration port for the input and output measurements to be properly read by the computer in combination with the resistors. This also happened for the potentiometers. These measure how much of something, which depends on the device that the microcontroller is plugged into, will be returned to create sound. Now, here are some of the cool sounds we made in our custom program to turn our computer into an instrument within the Pure Data graphic programming interface by twisting the potentiometer knobs to change our sound frequency and pitch. We also had several notes selected to play inside of the interface, being added and removed throughout, to result in a more complete creation. One can also notice how potentiometers allow for easy loop creation, as they remain at one spot on the frequency and pitch ranges until they are adjusted by a human.
I should be able to.
Oh yes, this is it.
Put these together. Guess I'll turn this way. So we got.
Okay, it's about to die. My life is about to die soon.
Hold on, record this though? I mean, like on your laptop.
Oh, yeah.
Well, she's recording on her phone. She can send us a recording.